The UCLA Institute of Transportation Studies acknowledges the Gabrielino Tongva peoples as the traditional land caretakers of Tovangar, where the UCLA campus lies today. We also recognize that the UCLA Lake Arrowhead Conference Center sits on the territory and ancestral land of the San Manuel Band of Mission Indians, the Uhaviatam people. We would like to thank the sponsors of the 2020 UCLA Arrowhead Symposium online series. Their support enables us to bring you today's program. In particular, we recognize the support of our session sponsor, the South Coast Air Quality Management District. This is an interactive session. To participate in this session, use Zoom's built-in chat, Q&A, and raise hand features.
Hello, everyone. I'm Juan Matute, the Deputy Director of the UCLA Institute of Transportation Studies and the lead organizer for this 2020 UCLA Lake Arrowhead series. I'm pleased to bring you this panel today on the air quality, safety, and well-being consequences of transportation impacts. Some of this research comes from the University of California's Institute of Transportation Studies COVID-19 Rapid Response Research Program. I'll place additional information on that research program in the chat, but it's a program that the UC system spun up in the spring of this year in response to the COVID-19 pandemic that addresses research needs related to the COVID-19 response and recovery from COVID-19. So today we'll be learning from three researchers in the University of California system about the impacts from the reduced travel that we've observed during COVID-19. Dr. Sunny Ivy from UC Riverside will be speaking about the air quality impacts, particularly in Southern California. Ofer Grebbuck and Seng-Hyuk will be speaking about traffic safety impacts throughout the California state highway system. And doctoral candidate Madeline Parker will be discussing impacts to individual well-being. Thank you for joining us today, and I'd like you all, so this is an interactive session, as my voiceover mentioned in the introduction, and I hope everybody can tell us their name, affiliation, and where they're joining from in the chat as we get this kicked off. And with that, I will turn it over to Dr. Sunny Ivy from UC Riverside for our first presentation.
Good morning, everyone. Thank you, Juan, for the nice introduction. I am Dr. Sunny Ivy. I am an assistant professor at UC Riverside. Today, I'm going to be talking about traffic, air quality, and environmental justice in South Coast Air Basin during California's COVID-19 shutdown. I'd like to acknowledge that this is a collaborative effort between the Sustainable Transportation Group at the Center for Environmental Research and Technology, and this project is led by Professor Shams Tanvir of Cal Poly San Luis Obispo. First, I'd like to talk about the motivation for this work. We've seen that so far there have been greater reductions in average vehicle miles traveled in, say, Orange, Ventura, and parts of Los Angeles County compared to the inland counties of Riverside and San Bernardino. Also, we've observed peak traffic reductions in mid-April, and those are rebounding toward pre-COVID levels. But we've observed that perhaps current traffic levels have not returned to pre-COVID levels. So the overall goals of our project are to understand and quantify traffic changes due to the COVID-19 shutdown, and we want to relate those changes to air quality and the spatial and temporal shifts in traffic. And we also want to draw conclusions about changes in pollution exposure as it relates to vulnerable populations in the South Coast Air Basin. So now I'll talk about the general methods that we use for each of these three parts of our project. Number one, for traffic flow, we're quantifying the changes in vehicles per hour. These data were obtained from the Caltrans Performance Measurement System. Okay. We conducted our analysis for stations along the major freeways in California, and we confined this analysis to the South Coast Air Basin. We considered traffic data from Tuesday, Wednesday, and Thursday between 3 and 7 p.m., excluding holidays. And our analysis stretches from March to June 2020. And as a note, our baseline is January and February. For our air quality analysis, we are considering changes in carbon monoxide, NOx, ozone, at the hourly temporal scale. And we've also done additional analysis with maximum daily 8-hour average that I probably won't talk about today. And the source of these data are the AQMIS system from CARB and also NOAA's meteorological deposit. So we've actually looked at the changes over 4 near road sites and 16 non-near road sites. And we've excluded missing data. So we've gone through and quality checked our data. We've computed diurnal profiles for 2020 and compared that to the average from 2017 to 2019. And in this case, that's our baseline. And so for our traffic comparison, we're comparing the weekly 3 to 7 p.m. differences, and I'll show that to you in just a second. For our environmental justice analysis, we use the 2018 Cal EnviroScreen 3.0 score. Okay, and this represents communities that have a high vulnerability due to pollutants and other factors. And these data come from Cal EPA. And so what we've done is we've extracted the static CES score for census tracts that intersected the traffic and air quality stations for our that we used in our analysis. So first, I'll start off by talking about the traffic flow changes during the first week of the shutdown. We've collected this data for District 7, and as you can see, there was up to a 30% change in vehicle miles traveled for total vehicles. And we've also presented the same for truck traffic. What we found is that most of the census tracts saw a drop of between 25 to 100% in traffic flow. Here I'm showing a time lapse of total flow change over the census tracts that we analyze. As you can see, the orange and the pink are somewhere between 0 to 20% above or below pre-COVID total flow. And as we progress into the shutdown, we see that those numbers become more significant and the level of traffic flow descends below 50 to 100% below the pre-COVID level. And we notice that this is most prevalent in the western part of the South Coast Air Basin. Next, I'm showing a time lapse of the changes in total speed. So the blue and the purple represent 0 to 25% speed change below and above pre-COVID level, so respectively. And so the other colors are going to represent where speed has increased as a result of less cars being on the road. So next I'm going to talk about the air pollution trends that we saw. And I'm showing you these data as a function of its location. There are locations in the basin. So these yellow sites are our upwind sites. These blue sites are our central sites, and the purple are what we call our downwind sites. At our near road locations, we see that the Anaheim, Vermont near road station generally has a percentage difference of 25% or below the 2017 to 2019 average. However, and that's for NOx. And however, for our Long Beach station, we actually see that levels are above what is expected for this time of year. We've analyzed our carbon monoxide concentrations as well as ozone, and we see some pretty interesting things. I won't get into the secondary impacts, but as far as carbon monoxide is concerned, once again, Anaheim, Vermont in the West Basin has the larger percentage reductions in pollutant concentrations for relative to this time of year. And in another depiction of these changes, we've looked here at the diurnal profile changes, or the changes based on hour of the day. And once again, this yellow star indicates our West Basin sites where the diurnal profile is less than 1 standard deviation from the 2017 to 2019 mean. And this is not so much seen for our upwind sites. And this is for carbon monoxide on the left, and this is for NOx on the right. Next, I'm going to talk about our environmental justice impact analysis. And so generally what we found is that traffic flow changed differently over the different census tracts as it relates to this CES score. So as a note, the high CES score means that this is a more vulnerable population in terms of socioeconomic and environmental exposure. And a low CES score indicates that it's a less disadvantaged census tract. And so we've looked at the spatial distribution of these flow changes as it relates to CES score, and we found that if you look at this time lapse, you can actually see where the percent change in flow increases from January to May, but also the change in flow is most evident for the low CES scores. The next thing I'm going to show is our depiction of the change in traffic flow as a function of CES score, as well as distance from the roadway. And I'm showing here the May change in NOx concentration versus CES score. And of interest is the fact that our near highway sites, they actually rebounded above concentrations expected for this time of year. And our arterial sites continue to remain below the average for this time of year. I'd also like to note that these near road sites are actually, or these highway sites and arterial sites actually are associated with a higher CES score, which is what we expect. We've also looked at the potential policy implications of our work. And so the one thing that comes to mind is telecommuting. And so we posit that access to remote work for EJ communities may be restricted by the nature of the jobs and technology. And so perhaps implementing incentives for businesses, specific businesses, will contribute to a reduction in this traffic burden as it relates to EJ communities. We also are aware that there may have been more of a consumption of online goods. And so that means that there's an increase in warehouse activity. And perhaps we need additional management for trucking activity in the Inland Empire region, since we didn't see the same level of flow reductions in the western or the eastern part of the basin. With that, I'd like to share a few takeaway messages and some of the conclusions that we've drawn as a result of our analysis. And so for traffic, we find that these COVID-related shifts are locally variable. And so from our PIMS data, we found that there were declines in traffic flow over the entire basin, but the recovery at different times and scales occurred differently over different regions. Next, for our near road pollution, we found that it does capture these trends, and we saw up to a 50% reduction in carbon monoxide and a 40% reduction in NOx. Further, we also saw these reductions in the non-near road locations. For environmental justice impacts, the results were spatially heterogeneous. So overall, we found that the flow decreases were generally more substantial for locations with low CES score. However, our air pollution reductions were not linearly associated with a an increase or decrease in CES score. So in the future, we want to answer this question, and we want to find whether or not there's an underlying reason for the flow reduction, whether there was more telecommuting or an increase in e-commerce activities. And with that, I'll acknowledge the Institute for Transportation Studies for supporting this work. And you can either contact myself or Dr. Shams Tanvir for more information about our project. With that, I would like to hand the speaker mic over to Dr. Alfred Grenbach of SafeTrack of UC Berkeley. Thank you.
Great. Thank you, Dr. Ivy. So I'm setting up my screen share.
All right, well, Dr. Grembeck sets this up. I just like to remind all of the participants that you can ask questions via Zoom's question and answer feature. And we'll be allowing you to ask those live in the second half of this presentation today.
Juan, can you see my full screen, or earlier there was a different button? Oh, I think I found it. Okay, I think it's good now.
Yes, we can see it.
Great. Hi, everyone. Good morning. My name is Alfred Grembeck. I'm the co-director of the UC Berkeley Safe Transportation Research and Education Center. And I'm going to be talking about some intermediate findings based on work that we're doing to better understand the impact of the COVID-19 pandemic on traffic safety. I will be giving the presentation, but this is joint work with Li Wei Fu, Praveen Vayalam Kuji, and Tanya Khom that will also be joining us for the panel discussion. So I'm going to dive right in and start by identifying what are the two possible impacts of a pandemic on traffic safety. So the first one, similar to what Dr. Ivy spoke about, and I'm sure all of you know and all of you have seen many times, the first one is the impact on exposure, which basically means the level of activity. As a result of the stay-at-home orders in California, there was a major drop in traffic. In traffic safety, less traffic means less exposure and potentially a reduction in the number of crashes. The second impact is on operations, and this includes both the perspective of the individual road users who might behave a little bit differently, but also from the perspective of how the roads are operated, with much less congestion being a very good example of how things can change operationally. Either ways, the operational changes are likely to trigger a behavioral response. That can be going faster, it can be going slower, it can be a variety of things that we don't quite know, but the circumstances have changed, and road users are expected to behave a little bit differently. Another important point is that the rapid rate of change that we're seeing here requires monitoring things at a higher frequency than what we are used to in the traffic safety community. So typically we look at things at an annual level, and we look at things, we need to wait until we've accumulated enough data to be able to analyze things statistically. And here, suddenly we have to analyze shorter periods of data to better understand what is the impact. So from a traffic safety community perspective, we had to change our mindset a little bit and look at the data on a weekly level, just because that is what was required in this situation. So we created this weekly injury crashes dashboard, and we update it weekly and typically even at a higher frequency than that. And I'll talk in a minute about the data that we're showing here, the data that is presented here. But in addition to the data, we're also allowing to, we also broke the data, or we can show the data across all of California, but also for 6 Bay Area counties separately, and then for 5 Southern California counties separately, so that we can actually see if there are any striking difference between the impact of Northern California and Southern California. Now the data sources. So we have 2 types of data that we're working with. The first one is police reported injury crashes, and that's what we consider the safety data. The source of the data is police reports completed by officers that responded to a crash. It's completed on a form that's called, in California, it's called the 555 form, and it has information about the crash. And then that data gets added to the California Statewide Integrated Traffic Record Systems, for short, SWITRs, and then that's uploaded to a website. But there is a delay related to submitting, processing, and tabulating the data. And we've learned that particularly the delay impacts the most recent 8 to 12 weeks. Now, there's this range of 8 to 12 weeks because both of them can get us to the point that we can conduct valid analysis. But of course, if we wait 12 weeks, we have a little bit more data than if we wait 8 weeks. And that's something that we keep in mind, that that prevents us from analyzing last week's data. Now, when I talk about 8 to 12 weeks of delay, that applies to highway crashes, mostly crashes that the CHP responds to, but can also be local police officers responding to crashes on highways. But when we look at crashes on non-state highways, the delay is actually much longer, and it makes it restrictive, or too restrictive, for us to analyze the data as of this point. So this limits the scope of the study, and it's an important thing to mention because all of the results and the conversation, most of the things I'll describe today, apply just to state highways. This, of course, includes the classic freeways, but it can also include major arterials across the state. But again, this is mostly highways, which means that a lot of data that we're looking at does not cover a lot of vulnerable road user activity. And again, it's not because we don't want to look at that, it's because it's a bit too early for us to be able to look at that in a representative manner. The second piece of data is exposure data, and that's we're using vehicle miles traveled to approximate exposure, and similar to Dr. Ivy's work, we're using the Caltrans performance measurement system. Over here, we are limited to loop detector reliability, but it does not suffer from a reporting lag, which means once the data is there, that's the most updated data that you have, as opposed to the crashes that the data constantly flows in, and every week you can have, in the first few weeks, you have a lot of data flowing in, and then gradually it starts to slow down until it matures. So basically what we did, we took these 2 data sets and we laid it out on this dashboard, the different weeks. Each row is a different week, and we have columns for the total number of crashes, the fatal and severe crashes, and the VMT, and we have it broken down for 2020 and 2019. If we look all the way on the last column, we can see the drops in VMT relative to 2019 similar to others, descriptions in the order of almost 40%, 37%, 40% that happened in late March and early April. When we look at the crashes, we can see that relative to 2019, there is again a noticeable difference that that tells us that things have definitely are very different in terms of safety. So we analyze this data in many different ways, but I want to focus on one aspect today, and that's a naive before-after comparison that we did. And we took the 6 weeks prior to California's stay-home orders. We're calling that the before data. We excluded the week of March 16th because that was a transitional week. That's when the stay-home orders started. And then we took the 12 weeks after that week as our after data. And now we're calling this a naive before after because we don't have good controls for here. We have 2019 as a potential control, but it comes with a lot of limitations. So what I'm presenting here is the naive analysis. Oops. So what are the findings? When first we started looking at all of the crashes, and there was a very big drop, and that's always very good news for traffic safety. But then when we started looking at this across different levels of severity, some other findings came up. So when we look at minor injury crashes, we see that the number of minor injury crashes, now minor injury crashes are either a complaint of pain or a minor injury. So that does not necessarily need to be a physical injury, but there needs to be a complaint of pain. But sometimes there's also a minor injury. So that number has went down from a weekly average of over 1,000 during the before to a weekly average of 551 in the after period. So this is a very big reduction, very good for traffic safety in minor injury crashes. But in traffic safety, you always care about the rate, and that's why we have the exposure data. And here, when we look at minor crashes, we're again seeing a big reduction in the minor injury crash rate. In this case, it's a reduction of 28% in the minor injury crash rate. And these are things that were reported also earlier on and are expected to some extent. But when we kind of focused our lens and looked at the crashes that more and more people in the traffic safety community have advocated that they are the ones that we need to focus on, we're seeing that we're getting a slightly different picture. On the one end, we're seeing that there is also a noticeable reduction in the number of fatal and severe crashes in terms of frequency from an average of about 120 per week to 94 per week in the after period. And this is a 22% reduction in fatal and severe crashes, definitely a good thing for safety. But when we're looking at the rate, and remember, because we have the VMT, we can actually calculate the rate across the state, we're actually seeing that there is an increase of 6.1% in the fatal and severe crash rate per 100 million VMT. So when we're starting to compare the findings about minor injury crashes and fatal and severe, we're suddenly getting a decoupling of this phenomena that is very important to mention. Now, how does this match with safety theories? So we do expect that less congestion would result in more speeding. If we look at the theory of planned behavior, and we look at the mechanism or the behavioral mechanism that can create a situation of speeding, we see that less congestion would result in an increase in the correlation between the intention, that's that circle in the middle, that's the behavioral intention, but that then affects the actual, the latent variable behavior that would be speeding. So if there is congestion, even if you do have the behavioral intention to speed, you won't be able to do that. When there is much less congestion, the correlation between these two variables would be much higher, and that means that there are a lot more opportunities, in this case, to speed. So what does this mean? We're seeing a major reduction in minor injury crashes, but we're seeing an increase in fatal and severe crash rates. So first of all, it means that the highways are not safer. There's definitely a higher fatal and severe risk per crash, but it also means that some of the thinking that we've historically had about traffic safety is challenged now. Some of you might be familiar with the traffic safety pyramids, and it's this conjecture that at the bottom are kind of conflicts, and as you go up, you get more and more severe crashes, and that there's some theoretical relationship between the number of minor crashes and the number of fatal and severe crashes. Um, but we're seeing here that both minor injury crashes and fatal and severe crashes were exposed to the same circumstances of the pandemic, and not only are they not changing in the same rate, they're actually moving in different directions. So what it tells us is that not all crashes are created equal, and that the impact is different, and we need to take that into account when we're thinking about traffic safety. How does this what are the policy implications of this? And I'm going to wrap it up from the Vision Zero perspective, or the safe system approach perspective, where there are all these principles that principles about how the safe system works and what are the highest priority things. But at the end, if you're talking about Vision Zero or safe system, it boils down to two elements. One is that users make mistakes, not intentionally, but that users will make mistakes. They might be late, they might be tired, they might be emotional. That's one aspect. And the second is that we need to build a system that can help survive the kinetic energy that the road user might be exposed to during a crash. So if you go back to this decoupling of the minor crashes and fatal and severe crashes, we see that only the um, um, fatal and severe crashes are the situations that you would be exposed to unsurvivable kinetic energy. And all of the crashes that are minor crashes that are probably more related to congestion, fender benders, maybe even parking crashes, are not crashes that would result in a situation that you can be faced with unsurvivable kinetic energy, at least on highways. So what are the next steps? The next steps are, well, there are just two here, but there are three in my mind. The next steps are, first of all, keep in mind that all of this was just on highways. City streets might even be more interesting. We do expect, once we get the data, we do expect that the situation will be even amplified. City streets, of course, have a lot more vulnerable road users, and the impact of speeding is even greater on them. So less congestion can mean that the rate of fatal and severe crashes in city streets can grow even more. We're already seeing in some other states that not just the rate has gone up, but for some states the frequency, also the frequency has gone up, which means despite the pandemic, there are actually more fatal and severe crashes happening on the streets, and we believe it's driven more on city streets. And the second part is we're conducting the next step of this research to confirm or check, is congestion indeed the pertinent factor here? Are we able to identify what crashes are caused by congestion, and then help take those out so that we can start thinking about highest priority crashes as the fatal and severe ones, and reduce the impact, importance, and maybe resource allocation for minor crashes as part of life-saving traffic safety programs. So then the third step is to combine all of these insights to see how can this help guide policy when we're talking about traffic safety. How can we make sure that we're looking not at all crashes together because the numbers are greater and it gives us more statistical power, but how we're looking just at the most important crashes. that are the fatal and severe crashes. And we're learning from this research that we have evidence that they might result from a slightly different causal mechanism, congestion versus more free flow crashes. Thank you.
Thank you, Belfer, and the Crows of Berkeley for that presentation.
Oh yeah, sorry for that. So yeah, as you can probably hear, I'm outside, and when my kids are noisy, I can yell at them. I tried with the crows, and it doesn't work.
All right.
So,
Well, now
I will pass it on now to Madeline Parker. She's a PhD candidate at UC Berkeley's Department of City and Regional Planning.
and as Madeline queues up, just a reminder, you can ask questions via the Q&A feature and also vote and comment on questions.
Thank you. And thank you all for joining this morning. Is my slide queued up?
Yes, it is. I can see it.
Great. So I'm going to be presenting on behalf of our interdisciplinary team listed here on our work examining travel behavior and compliance with social distancing and shelter-in-place rules. I'll be sharing some of our findings related to changing travel behavior and its relationship with well-being in the past few months. And we'll begin by describing some background on our survey before demonstrating some of our mobility-related results, well-being-related results, and data tying the two together. So to understand this behavior, we've been very fortunate and grateful to be partnered with MB Mobile, a mobile audience analytics firm. And they've allowed us to analyze and develop behavioral insights from their data set. The panel they have is more than 100,000 individual panelists across the United States, representative of the US population. The data that MB is collecting is on two fronts: location data at the individual level and app and web use data. MB panelists agree to share their data and are compensated for taking part, as well as for taking additional surveys offered through the platform. Here's a timeline of our overall approach, which involves three primary branches. As we've been interested in understanding a holistic picture of mobility patterns, we have access to passive behavioral data from September 2019 through now, which gives us the ability to observe people's actual behavior and mobility patterns before and during the pandemic. In parallel with that, we've also been doing comprehensive policy tracking to track both location and timing of various policy interventions that took place over this time period in order to examine the impact of policy guidelines on behavior and other actions related to mobility. And to capture the factors affecting individuals' mobility, we started survey collection and designed and deployed the first wave of the survey in August. So what I'll be showing today is therefore still an early stage of research, which we think has interesting findings and shows promise as we develop our work further. The survey has been at the heart of our work, and this is a high-level graph showing the factors we included in it. Activity or travel behavior is the outcome of interest. Our broader research questions around travel behavior and compliance with social distancing and shelter-in-place rules. We recognize that people's activity is dependent on many other factors, including ones that are economic, social, related to political views, and many other things that we know affect travel, many of which we mapped here in this framework. I'll be focusing on certain findings relating to travel and well-being today, but wanted to show this just to demonstrate how we designed the survey on a whole and the range of questions included in it. We developed the survey with the goal of being able to observe these variables in order to control for them and isolate effects of policy interventions. So just for example, in terms of economic factors, we asked whether or not someone had experienced a loss of employment and when that happened, as we'd expect a change in their mobility behavior, and we want to be able to attribute that change. Our survey has 78 questions total, and we tried to be representative demographically and geographically. We targeted the survey at a diverse mixture of counties here shown on the map, with concentrations of MB panelists. We have about 1,200 responses from Wave 1, which was deployed in August, and are currently gathering responses from Wave 2. I'm now going to describe some of our mobility-related findings. This graph shows the average number of separate weekly visits our respondents took. Each trip essentially involves a check-in at a different location, like school, work, or grocery store. The range and that band you see, it shows the 90% margin of error. In some weeks, we don't have mobility information for everyone in our sample, which is why some weeks have higher peaks than others. I've included sample sizes of survey respondents on the graphs, but the number of those that we actually had mobility data for varied week to week through the graph. There's also more variability in movement in some weeks than others, so our variability is high relative to our sample size. You can see here the significant drop in the beginning of March and a slow return to close to pre-pandemic weekly trip levels. Most of our information on our respondents comes from our survey, which was in approximately week 32 to the right side of this graph. We see similar results when looking at weekly trip distances. So this graph shows the total distance traveled per week, averaged out across our respondents. And for example, this spike in week 22 may be related to more variation around Memorial Day weekend, or just to having a smaller sample size that week. In this graph, the red line is indicating conservatives, examining the mobility of those who'd identified their political leanings as conservative or very conservative. And the blue line indicates those identifying as liberal or very liberal. You can see that the two lines have similar trends, and geographic factors may relate to why the conservative weekly trips trend higher than liberal overall. Our sample size here is quite small. There's a lot of variation in our error bars, and we're not seeing statistically significant differences across groups. This graph is examining responses to our question about whether people agreed with the statement that social distancing stops COVID-19 from spreading around. The red line in this graph indicates those who disagreed with the question, while the blue line indicates everyone else. There's a lot of variation, especially in the smaller group of those who don't believe in social distancing, though we do see a few weeks where those who believe in social distancing had less weekly travel than those who didn't. In this graph, the red line indicates those who do not have access to a private vehicle in their household, while the blue line indicates those who do. We can see a distinct difference in the number of weekly visits, both before and after the start of the pandemic, when looking at those with access to a private vehicle and those without access. It's hard to piece out this precise trend due to the margins of error, but from the lines it appears that those with access to a household vehicle had a greater decrease in weekly trips in March than those without, echoing discussions about the ability to shelter in place as a privilege for those with jobs and circumstances that allow them to work from home. In this graph, the red line indicates those who are affected by transit cuts, and the blue line indicates those who were not affected. Our specific question here asked, have cuts in transit service since the COVID-19 pandemic began, March 2020, been an issue for you? And those affected include those who said that they have been a minor or significant issue, while those unaffected includes those who said transit cuts haven't been an issue, there have not been service cuts, or that they don't use transit. Here, while there's more variation than in the previous graph looking at vehicle access, there are distinct differences post-COVID between those who said that they have been affected by transit cuts. And finally, this looks at characteristics of those who said they were affected by transit cuts compared to those unaffected. You can see that respondents affected by transit cuts are more likely to not have access to a vehicle, be people of color, have a decreased income since the beginning of the pandemic, be living in an urbanized area, and have caregiving responsibilities than the other side of our sample. I'm now going to describe some of our findings related to well-being. We included depression and anxiety screening questions from the 4-question version of the Patient Health Questionnaire, which is used as a quick way to screen for anxiety and depression, and has been validated and tested by a wide number of studies. It's currently being used in the Safe Campus surveys on Berkeley's campus, as well as by the US Census's Household Pulse surveys. We found that approximately 30% of our sample screened positive for depression or anxiety, with 22% screening positive for both. This number may seem high, but it reflects findings from current literature, which have found that the previous 8.5% depression rate has tripled since the beginning of the pandemic to approximately 28%. We also included questions asking about physical health, isolation, and how much longer respondents felt they could endure the emotional and economic impacts of COVID-19. They'll be focusing on our PHQ-4 questions here. Respondents who screened positive for depression were more likely to be female, have a decreased income since the pandemic, be caring for an elderly or disabled person, or have a young child at home. And finally, I'm going to show some of our findings at the intersection of travel and well-being. In this graph, the red line indicates those who screened positive for depression, and the blue line indicates those who screened negative for depression. We found that there was no significant difference in weekly trip numbers between those who screened positive or negative. Our wide error bands make it hard to say. And again, this variability and the wide error bands may be related to our sample size. I also want to remind when looking at this graph that we don't have data on the depression or anxiety screening questions pre-pandemic, so they're only coming from our survey in approximately week 32. When looking at total distance traveled, we see large error bands, as we've been seeing in these graphs, as well as peaks on certain days, possibly due to variability related to holidays or smaller sample sizes. We do see a statistically significant difference in mid-July between the groups. In this graph, the red line indicates those who screen positive for anxiety, and the blue line indicates those who screen negative for anxiety. You can see that the results from our anxiety screenings are similar to those for depression, with no significant differences across groups. And these total distance traveled lines for those who screened positive for anxiety and those who didn't follow similar trends to the results we saw from our depression screening, with a significant difference in July, but similar trends overall. This graph is looking at the depression screening results for those who reported that they did not have access to a vehicle on the left, compared to those who did on the right. The red indicates the percent screening positive for depression. You can see that the differences are very small, both at around the 30% sample average, and this difference was not statistically significant. These are unadjusted results, so they aren't controlling for anything and for our whole sample. And this result was a bit surprising given literature on mobility access and mental well-being and the socioeconomic factors usually related to vehicle access. Two factors that might be related to these numbers include the fact that we asked about household vehicle access, so the number of vehicles available for regular use by people living in your household. We also have very few respondents, under 15%, who live on their own, so this might mark access to a vehicle that in reality respondents don't have regular access to. There might also be other factors related to vehicle access and the fact that we included portions of many large cities in our sample. This graph is examining the percent screening positive for depression by whether or not they reported being affected by transit cuts. Those who reported not being affected are on the left, and those affected are on the right. Here, the group who were affected by transit cuts has a higher average rate of screening positive for depression, at 40%, compared to those who reported not being affected by transit cuts at 27%, which is a statistically significant difference. And these results do follow in line with literature on mobility access and psychological well-being. These results are also unadjusted for factors like income, and there may be other factors and variables tied up in our transit variable. And so this graph shows the marginal probabilities for screening positive for depression by whether or not respondents were affected by transit cuts, while also adjusting for socioeconomic and demographic characteristics. Here, we controlled for characteristics indicated from the literature that may be connected to depression, and these characteristics that we had information on from our survey, as well as factors that we thought might be related due to current circumstances. So the characteristics that we controlled for included having a decreased income since the start of the pandemic, having not worked in the last week, being a person of color, having a low income, financial insecurity, being an essential worker, vehicle access, gender, age, having young children, living alone, knowing someone infected with COVID, living in an urbanized area, crowding at home, and having caregiving responsibilities. I want to emphasize that this is an association and not causation. We unfortunately don't have this screening data prior to COVID, so we don't know if this association held before then. But you can see that there is a positive association between being affected by transit cuts and screening positive for depression, even when controlling for a wide range of characteristics. These findings are in line with a body of literature exploring the links between well-being and mobility and supporting the association between psychological well-being and access to transportation. In thinking about the relationship between transit cuts and people's well-being, We asked a questionnaire survey about what factors respondents felt would contribute to their return to transit, thinking about increasing ridership as well as ensuring that transit is a comfortable mode for people to use. We asked which of the following measures would increase your use of transit. You can see that the top factors listed were about sanitation and cleaning, widespread use of face masks, an effective COVID-19 treatment or vaccine, reduction in COVID-19 rates, and reduced crowding, all of which had more responses than the factor of returning to regular service levels, while 10% of our sample said that they were already comfortable taking transit. And just to note that these percents don't sum to 100 as it was a select all that apply. So in summary, these are the findings that I've displayed. Just to highlight, we did not see a lot of significant differences in weekly trip numbers between many groups, but people who did not have vehicle access or those who were affected by transit cuts were and continue to travel less than those with access to vehicles or those unaffected by transit cuts. And while those who screened positive for depression or anxiety did not have very different weekly trip numbers or total distances, we did find that transit cuts are associated with higher rates of depression. As I mentioned at the beginning, we are in the early stages of our analysis and in the middle of data collection. Wave 2 is live and collected in responses at the moment, and we're continuing to process our mobility data, tracking policies and directives, and are in the design phase for our next survey wave. What I've presented here is just one portion of our survey results and our broader effort, including processing and analyzing passive behavioral data, still continues. We're excited about the potential of our broader research on mobility patterns and policy interventions, as well as how all of these factors may be changing over time as we see continued shelter-in-place orders across the country. And we really look forward to your comments and suggestions for our future analysis. I am just one of a large interdisciplinary team. These are my other team members, a mixture of undergrad, graduate students, as well as faculty members across city planning and engineering. Amin and Joan are also in attendance today and will be joining for the panel. And I want to thank our sponsors and mobility partners who made this effort possible, including Citrus and MB, and to Arrowhead for organizing today. If you have any further questions or suggestions as we continue our work, feel free to email me or our PI, Professor Joan Walker. I'm going to hand it back to Juan.
Thank you, Madeline, for that fascinating presentation on the connection between transit service cuts and those depression impacts. I think that eventual academic publications from this research will be influential in thinking about post-COVID transit recovery and the needs there. So now I'm going to turn it over to my colleague, Jacob Wasserman, who's been chatting with a few of you in the audience about posing your questions online or on camera. And I'd like to invite the panelists and others who have been involved in their research to turn on their video and be prepared to address some of these questions. So Jacob, can you introduce our first questioner?
Great. Thanks so much for everybody for these presentations. The first question is from Madeline Brosen at the UCLA Lewis Center for Regional Policy Studies.
Thanks, Jacob. I want to thank all of the presenters for their work in this panel. Also, I know doing work in a COVID recovery when things are changing week to week makes this work even harder. So thank you all for that. My question is to Dr. Ivy and then a little bit maybe to Offer and the Collision team. But I was wondering first if you could just kind of expand a little bit more on kind of one of the points you ended on, which is about this heterogeneity. Maybe you could kind of help explain that for those that might not be familiar with that term, but just about where the volumes change versus where the actual and then the kind of related pollutant part. It sounded like there was pretty different parts of that kind of based on vulnerability of communities. I wonder if you could talk about that. And I don't know if this is something that you've looked at in the collision data about kind of the spatial part of that as well, but I'm curious on that. Thank you.
Thank you, Madeline. I may have you repeat parts of the question. Thank you. It's very in-depth. So first I'll talk about heterogeneity. So what that means is that changes over space and time are different. Then you asked me about flow changes and the differences between air quality changes. Is that correct?
Yeah, it
So-
sounded like the flow changes versus the air quality were kind of in different places. Yeah.
So when it comes to congruence between flow changes and air quality changes, that's most apparent at our Anaheim near road site. Okay, so we have reduction in NOx, reduction in CO, which aligns with our top percentile reductions in flow compared to your Orange County, your Los Angeles counties, and your Riverside, San Bernardino counties. So there's this play between commuter vehicles and heavy duty vehicles. So the heavy duty vehicles are going to have higher NOx emissions per mile traveled, whereas your commuter vehicles are going to have higher carbon monoxide emissions per mile traveled. So when you change those ratios, you inherently change the flow, and you have differences in air quality changes based on those changes in ratios and fleet composition. It's very nuanced, and I'll invite Matt to chime in if you want. Matt Barth. Professor Matt Barth is the director of CSERT. He's a collaborator on this work. And so when it comes to environmental justice, we know that you have a high environmental justice score along the roadways, right? And since we have differences in the way flow changed, we're going to have differences in how pollutants changed, because the fleet composition and the level of flow that changed in East Basin versus West Basin is different. And then that's just for primary air pollutants. When it comes to secondary air pollution like ozone, the trends are completely different. And I didn't show that today. So, and you've also got to think about how these pollutants are transported in the atmosphere. Carbon monoxide is slightly longer lived than NOx or than NO. During peak daytime hours, NOx is consumed by the formation of ozone. So our project was incredibly, I would say it's multiply derived. We have to look at things from several different angles, and we're somewhat data limited, but from what we've been able to see, primary traffic related pollutants are most associated with flow changes, but the EJ conclusion is a bit muddled at the moment. I hope that answers the question.
Yeah, I think it was just trying to unpack that. There was a lot there. That was really helpful.
Yeah,
Matt, did you want to make
I can chime in too if that helps. Yeah, everything Sunny said makes sense. I mean, obviously the whole transportation air quality relationship is complex. Not only do we have mobile sources, but stationary sources, and then we have dispersion that goes on and how long the pollutants last. But the general trend is true. I mean, we saw a reduction in traffic flow, and we saw reductions in measured pollutants in the atmosphere. And then it's even more complex because you have some air quality stations that are measuring away from the roadways and others that are closer by. And so you got to take that into account too. But I think in general, we're able to see the correlation between those things. And then part of the next steps is to do a deeper dive on differences between what cars are doing and what trucks are doing, right? So we have an increase of e-commerce, and we can trace that a little bit better with NOx measurements compared to CO, which is what we're using to look at from the regular commuter traffic. The last caveat I want to make, though, is this is all based on the Caltrans PEM system, which is only highways, right? And so we know that there's a lot of differences going on too with the arterial roadways, but getting arterial roadway traffic information is hard. Cities do it differently, and there's not a central database for all that. So we've been able to pick up a little bit here and there on the arterials, but we haven't completed that analysis yet. But anyway, it's interesting to see these two things happen at the same time.
Jacob, could you queue up our next questioner, please?
Yeah, we have a question from Nancy Pfeffer about e-commerce.
Hi, everybody. Boy, it's great to see at least a few arrowhead faces and to be seen. So I'm just, my heart is there in that room with all of you up in the mountains. Yeah, I asked a question that is kind of a context question. Some of the presentations made me want to stand back and understand better what we know about the comparative environmental, or let's say air quality impacts of e-commerce versus sort of traditional retail shopping trips. I have wondered about this question for many, many, many years. And I've also seen some very sort of off the cuff, discussions of it in forums and what have you, but I'm really wondering if there's been any rigorous study of, whether we should expect a net air quality benefit from greater use of e-commerce as compared to our traditional shopping trips. And again, that's context that applies even beyond the pandemic, since we already were in that trend and the pandemic has somewhat accelerated it. So I wanted to understand the status of scholarship on that. And I appreciate any and all info. Thanks.
Hi, Nancy. I can take a stab at that question. So there has been a lot of anecdotal evidence, obviously, between what we've seen on the roads and trade-offs between whether you decide to make the trip to go shopping versus whether you have it delivered to you. Miguel Joller up at UC Davis is studying this problem as part of the National Center for Sustainable Transportation. So I would definitely look at his papers. He's looking into that and going beyond just anecdotal evidence, looking at the data and seeing what can be derived there. I think there was a question too about, can we actually measure differences between car flow and truck flow on the roadways? And the answer is yes. The California PEM system for measuring traffic, you can figure out a ratio. There's a methodology for estimating the ratio of cars and trucks. It's not super reliable, but at least gives us a general indication of that ratio between cars and trucks. But there's not a direct measurement of how many trucks and direct measurement how many cars, but the ratio we can figure that out. And again, as I said before, there's a big gap in information when you get to the arterial roadways.
And I can jump in here also, Nancy. It's a great question and really important right now when we're seeing all the changes in this with COVID. So I would point you to Ann Goodchild at the University of Washington. So she's done work looking specifically at this environmental impact. And then on the behavior side, where I have a PhD student with Susan Shaheen, Teddy Forsher, who's doing surveys and trying to understand how e-commerce has changed over COVID and what will stick. And also there's a UTC out of Northwestern that Susan and I are involved with, led by Hani Mamasani and a lot of other great people who are looking in particular at this issue and using COVID as a natural experiment to understand what is going to come from that.
And just a programming note, we'll have a session this afternoon, actually, on changing trends in travel behavior. Will they last? And presentations on substitution of accessibility for mobility, including work from home and e-commerce and substitution for brick and mortar shopping. Okay, I would like to take a moderator's prerogative and ask a question of my own. For your area of research, how are the observed travel changes during this essentially natural experiment going to impact the understanding of the system you study and the modeling and forecasting going forward?
Can try.
Okay.
So Juan, your question is, how would this impact our modeling and efforts moving forward?
Yeah, we have a natural experiment on a grand scale
at
this time, and it seems like there are resources studying it, hoping to learn from it. Right now, we don't yet know what will be statistically significant, so this might be more of prospective, what one might hope to learn from this reduction in travel and gradual ease back up. for traffic safety, for the impacts of
Yeah.
transportation on air quality, and for our understanding of utility derived from travel.
Yeah. So I'll try talking about safety. So the safety world in the past 10 years has gradually tried to overemphasize fatal and severe crashes. But a lot of the discussion still included, a lot of the analysis still included what's called PDOs, property damage only crashes, and some minor crashes. And there's always been that conjecture that a crash is a crash, and if you're able to allocate resources to prevent any crash, then it will eventually trickle up to the safety pyramid and would also have an impact on fatal and severe crashes. And from what we're seeing from this natural experiment is that the minor crashes and the fatal and severe crashes were exposed to the same change, the same circumstances, and the minor crashes, the rate went down by quite a bit, but the fatal and severe went up. So there is a decoupling of the causal mechanism of these crashes. And what we intend to do moving forward is to further solidify that not all crashes are the same. And we need to better understand the mechanism that causes the fatal and severe crashes where we're exposed to unsurvivable kinetic energy as a car occupant, as a pedestrian, as a cyclist, and better understand how to just try to prevent or prioritize preventing those type of crashes and underemphasize minor crashes that are definitely a burden on society and have an economic cost, but are not catastrophic.
All right. And might the UC Riverside team have some thoughts on what we're going to learn about air quality modeling from not just the data you're collecting for the study that you've presented today, but other data that's collected and analyzed, collected during this period and analyzed into the future?
I can take that question.
Okay.
I'd say we are learning a tremendous amount about the Earth system as a result of this unfortunate event. There is a large group of researchers working together to understand global, regional, and local scale impacts on air quality, on carbon emissions, and this effort is being led by the Caltech Jet Propulsion Lab. And so we're working on this collaborative paper that will eventually be submitted to the proceedings of the National Academy of Sciences publication. So what we do in the air quality modeling world is we conduct what are called like sensitivity tests, where we'll perturb an emission and then we look at the model response, right? Or we'll perturb a boundary condition and look at the model response. And so unfortunately, this was a huge sensitivity experiment. And with the data we have from folks like Matt, we have actual traffic flow counts and reductions. We know exactly how to perturb our models and understand the impacts on air quality. This has really strong implications for non-attainment as well. So if we know roughly the delta in traffic and then the delta in air quality, we can tell whether or not that will allow us to meet the standards in the future, right? Whether it's gonna be enough. And so I think our local air district, I hope someone's here, is interested in understanding those impacts as well. So.
Just a couple additional words. So I think everyone's aware that there's a recent growth in these low-cost air quality monitors. So we rely on the expensive equipment that the South Coast AQMD and others deploy. But now there's these lot less expensive sensors that are out there that have a little bit higher uncertainty to them, but getting those larger numbers of these measurements is certainly helping with both the air quality modeling and how we can correlate that with traffic information. So that's out there, and that's actually the basis too of the AB 617 community analysis, right? So how can we measure how are the air quality is changing, and then how can we again correlate that with traffic changes. So there's a lot going on in this area, and so I think there's going to be a lot of new things that'll come out of it.
And I can try to jump in one on the travel demand side. So yeah, it's a great question. You know, I feel like it used to be our concern was forecasting autonomous vehicles and TNCs, and now everything has gotten shaken up. So the whole question is what will stick. We have this big natural experiment. We have this major change in travel behavior. And with behavior, when you have people able to experience different things, this is forcing people to try new things, try e-commerce, telecommuting. And so the question is what will stick. We look at the changes to mode choice, feelings about transit and TNC, even changes in longer term decisions like residential place now that we aren't tied so much to where our work location is, and e-commerce and telework. And so there's just a lot of interest in this for sure. And I think it's going to be a blend of the dynamics is really important. So looking at how these things are changing over time. So these big data sets are really useful for that. Of course, they're shallow, right? They don't have the detail we want, and blending those with the in-depth surveys so that we can really understand and get more detailed information. But that's where we're going. It's an exciting time. I mean, to study behavior when there's so much change is fun.
Thank you. Any other comments from panelists who didn't get to address this question? Okay, I'd like, Jacob, do you have another question queued up from an audience member?
Yes, we have a question from David Sforza. David.
Good morning, everyone. My question is for Dr. Grembeck. Do we know if looking at other states that are using speed enforcement cameras, if we're seeing a decrease in speeding during COVID-19, or are they also seeing an increase in speeding regardless of the enforcement effects?
That's a good question. Enforcement, so again, in California, there's no automated speed enforcement or speed cameras. So this is, of course, a question based on what we're seeing in other states. And there are some evidence that speed has increased regardless of automated speed enforcement. And the reason is that also even automated speed enforcement does not eliminate speeding. It does help reduce a subset of that. So if the overall speeding events go up, the overall speed will also go up. So it has an impact on some speeding situations, but not all of them. So it probably has the same impact, just on a larger number of incidents.
Okay, thank you. Jacob, do you have any other questions from participants?
Just getting one queued up, but if you want to jump in now.
Oh, okay. So these are both challenging and interesting times. And I think as researchers in the academic community, we try not to make gut predictions. But I am wondering if you have any insights into any currently observed phenomena, behaviors, consequences of travel that you think might stick beyond the COVID-19 period. So either a key learning for government, a change in behavior, or just a difference in approach to problem solving and policy making. We'll start again with the SafeTrek team. That seemed to be a good order.
Sonic, do you want to provide some comments? No. So in terms of how would this affect
Well, so yeah, I mean, just one example, the last questioner, we know that during a time like this, it's difficult to make sudden changes in engineering to adjust speeds if we know that there is an increase in severe and fatal injury crashes and the rate rather. And it does seem that part of this series is related to social equity and racial equity, and it does seem that there may be, perhaps for your area of purview, and the last questioner's comment, an opportunity to move forward to automated speed enforcement from this confluence of our understanding of how when congestion reduces, maybe the rate of fatal and severe crashes might go up. And so that might be something that sticks. I know it's very prospective in terms of forecasting what may happen, but so that could be an example.
Yeah. So so as you said, it is hard to make design changes, but it will definitely highlight the need to make design changes to reduce the crashes that are the most catastrophic. We do expect that things will not be back to normal, that will be a little bit different, but we talked a lot about the highways, but there's also the local streets, which are not covered because we don't have the data yet, but that is also relevant to your question. Because for the local streets, we are seeing that, and I saw there was a question about it, we are seeing that many cities are implementing slow streets activities and are making kind of quick design changes or operational changes to their streets. And these are things that, again, we don't have the full data to assess the impact of slow streets on safety yet, or at least from some big cities that we're looking, we don't have the data yet, but we have reason to believe that that would also have a positive impact, or that would have a positive impact on safety. So moving forward, I think it also creates opportunity for more flexibility and more operational changes that can accommodate lower speeds and encouraging of more vulnerable road users, more on the city streets. So I do anticipate that this would allow us to, or opens up more opportunities to making operational and potentially design changes on city streets to provide better protection for vulnerable road users.
Any other thoughts that any of the panelists would like to share on this?
I guess I can jump in again that in our project, we're really not focusing on the travel behavior so much, although because we're transportation people, it's in there. We're really focusing on compliance and trying to understand how, shelter in place guidelines, mask wearing guidelines and things, and how people are reacting to that. So I guess I would say, and we're analyzing that now, so we don't have results, but we're looking at the shelter in place in particular, whether, because everyone dropped their travel, right? So by putting in shelter in place, does it actually make them drop more, or what happens there? So we're trying to analyze that. And then we're also, the dynamics of it is important. So this concept of having the waves over time and being able to see. So the mask wearing, we just have to ask people, we can't see the movement, but we're asking people in these waves how they feel about mask wearing, how often they are mask wearing, are they social distancing? And we're trying to understand the dynamics of this and how policy can influence it, hopefully in a healthier direction.
Mhm. And yeah, I think with the mask wearing, people use that intervention because they have some understanding of how their actions affect others, which is, a core problem of public policy and urban planning is addressing these problems at scale. Uh, Dr. Ivy, I was wondering if you had any comments on, maybe because people are learning, that if they have the virus, which they could be asymptomatic, they're shedding the virus, they can affect others by breathing, sneezing, being in the same room as them. I know in your research, and one of the concerns that you expressed in our preparatory call is that when it comes to transportation systems and air quality, people don't always think about how their actions affect others. I wonder if you might share some comments on what you hope people would take away from this period.
Okay. I truly hope that people can begin to view their actions as part of a collective effort to thrive, right? The U.S. has a history of rewarding, rugged individualism, which serves us. It serves us well. It leads to innovation. It leads to a lot of advances in technology, economy, et cetera, et cetera. I think this unfortunate situation brings us back to the fact that we do need to act as a collective. And in terms of air quality, when enough people change their behavior, we can see huge perturbations in emissions. But I don't want to put this all on people, because a large contribution to air quality comes from industry. Okay. This isn't an industry panel, so I'll reserve my thoughts about that. But in terms of transportation, with advances in engine technology, electric vehicle technology, combined with our willingness to shift the ways that we go about business or work from home, can have significant benefits for air quality. I do believe that. I think we all have to have a collective willingness to do that, to shift our behaviors.
Yeah, thank you for that comment. We have one final question. Brian Peck from VSP.
Sorry. Good morning, panelists. First off, I want to say thank you for presenting your research. I found it very interesting and insightful. I have a question for Dr. Ivy. In one of the charts that you displayed, I saw that VMT has reached pretty close to pre-pandemic levels. And that surprised me a little bit, given the amount of working from home that has persisted throughout the pandemic. So I was wondering what your thoughts were as to what this is attributable to. Is it because there's more deliveries or greater demand for essential workers, or some other reason that I'm not thinking of?
Hi, Brian. Thank you for your question. I'm going to answer it partly, and then I'm going to hand it off to my collaborator, Professor Barth. Just from my lived experience and anecdotally, at least where I live, there's not the same level of traffic, but there is quite a bit of commuter traffic and it's different from, say, the April peak reduction in traffic. So why that is, I'm gonna pose that question to Matt. I don't know what people are doing out here.
Yeah, no, I mean, this is sort of out of our area, right? I mean, it's a behavioral issue, right? I mean, I think people had that initial shock. They stopped driving. They did a lot of work at home, and then they slowly became more and more comfortable to going back to making some trips out to various places, visiting different things. So it hasn't completely recovered, but it's certainly tailing up towards that direction. I think it's more of a behavioral issue, and maybe Joan has a better answer than that. So, and, and we should say that, yeah, e-commerce is certainly up, right? So that is part of it.
Mhm. Yeah, it is a tough question, and I do think we have an unequal distribution of the impacts across economic class, in particular, but also other socio-demographic variables. And some of those we'll be exploring in the 1:30 session today. So mark your calendars, and you'll be able to access that session the same as this session. So I'd like to thank you all for joining as panelists and your contributions to knowledge in general and to this series. And I'll be closing out the session now. So thank you very much. And I'd like to also thank again our session sponsor, the South Coast Air Quality Management District, for their support of the series and this session in particular. And as I mentioned, our next session on those changing trends in travel behavior, will they last, begins at 1:30 p.m. Pacific time. Again, it'll be an interactive session with opportunities to ask questions of the panelists. For more information on this session and the rest of the series, you can visit ucla-arrowheadsymposium.org. And immediately after this session, right now actually, we can jump to breakout rooms. So I've seen a few familiar faces from the prior in-person Arrowhead Symposia in the audience, and what we've been trying to do is recreate as much as we can of that experience. We've recognized that those times between sessions, those breaks, those social hangouts, and even the meal times are really an important part of connecting with people, processing what we've learned in these sessions. So we have those. We've replicated that in the form of some breakout sessions. So please join the link that Whitney has put in the chat. I and some of the others will be in there. We invite all of our speakers and panelists to catch up if you have additional questions. So I see several of you are jumping over there, but you'll be able to find a space that's familiar to you if you've been to the UCLA Arrowhead Conference Center. And like to thank Farron Pierce for sponsoring today's breakout session. All right.